Let's use this circuit to explore phase shift measurements between two signals in Multisim Live. We start with a source voltage, which is 208 volts RMS. Next, we have R1 and L1, which you could think of as the reactance of a generator. Normally, we wouldn't put in this 0.001 ohm resistor. It's negligible relative to the rest of the circuit. However, it must be there in order for the simulation to run correctly. You cannot put an inductor directly onto a voltage source. We have L2 and R2, which could be thought of as a motor. And we have C1, which could be thought of as a power factor correction capacitor. We're going to add a probe that measures both voltage and current. When we run the simulation, we get the instantaneous results. That's not what we want. Instead, we want the periodic results. And when we do that, we see 208 volts RMS, and we see a current of 37 amps. At this point, we're going to run the grapher. Quick note, if your oscilloscope is running right now, in the upper right, be sure to shift it into normal mode. What I'm doing right now is I'm hovering over the axis, and then I'm moving the scroll on the mouse. You can do that with voltage, current, and with time here. To make these measurements easy, we're going to add cursors. You see cursor 1 is linked in right here with the dark green, which is voltage. And we're going to set that all the way to the beginning. By the way, note that this is an inductive circuit. You know that because the current is lagging. Speaking of current, we're going to shift C2 so that it does indeed measure the current. And if we look down here, we see the current is about 52 amps, but that's a peak. The actual current is about 37 amps RMS. At this point, we can start to measure the phase. Be careful here. The axes, you can slide them like this. You want to make absolutely certain that both of them are indeed on the same zero. When we do that, we can slide cursor 2 over to zero current. And remember, cursor 1 was already at zero current. Correction, it was already at zero voltage because that's what we're triggering off of. When we do that, we see we get about 1.55 milliseconds. That is the difference, the time difference between the two cursors. If we go back to pen and paper, we know that this is a 60 hertz circuit, which means we should have about 16.6 milliseconds as the period. To measure the phase, we establish a ratio where we say that 1.55 milliseconds is to 16.6 milliseconds, as x is to 360 degrees. Solving for x, we find that the phase difference between the voltage and current is 33 degrees. At this point, we'll quickly go through the circuit calculations so you can see that what we put on paper matches the simulation. We start by saying that 208 times root 2 is 294 volts peak, which is what the simulation called for. We then calculate the reactances of the inductors and capacitors. We enter the impedances of the inductor and capacitors on the schematics so that we don't forget what we're doing. We draw a box and we calculate the impedance of the parallel components inside that box. From there, we can calculate the total impedance. I should make a note that that 0.001 ohm resistance is negligible in this calculation. We did need it for the simulation. And finally, we calculate the source current, which is 37 amps RMS at an angle of -33 degrees.